Okay, this is lesson 3.1, and we're using the intermediate value theorem to prove 3x to the fifth minus 4x squared equal 3 is solvable on the interval from 0 to 2, on the closed interval 0 to 2. Okay, so first we're going to, here's our instructions from the previous video. We want to define the function, define m, establish f is continuous, choose an interval. Well, we already have an interval, 0 to 2. And establish m between f a and fb, where f of a is less than m, less than fb, or the other way around. F of a is greater than m, greater than f of b. Okay, so we're going to define our parameters for our proof. Let f be a continuous, let f be a continuous function let f be a continuous function such as f of x equals to 3x to the fifth minus 4x squared on the closed interval, from 0 to 2. So we've just defined our function, established that it's continuous, and we established our interval, which is given. We want to assume that m equals 3 is between f of 0 and f of 2, and then there exists at least bring this up, there exists at least one number c, on the interval 0 to 2. And which satisfies f of c equals to 3. Okay, so f of c being whatever is going to be put in there to equal 3. All right, so there we go. We've defined our function. All right, now we need to establish that m is between f of a and f b. We've established m is 3. We established our function, which is 3x to the fifth minus 4x squared. And we established our interval. So therefore, since let me use green this time. F of 0 equals to 3 times 0 to the fifth minus 4 times 0 squared equals 0. We can say that f of 0 is less than 3. All right. So, and now we took the left end of the interval, right? Plug that in. Now we're taking the right end of the interval and plugging that in. is equal to 3, and then 2 to the 5th minus 4 times 2 squared. And calculating that out, that comes out to be 80. So f of 2 is greater than 3. So from here, so therefore we've established that f of a is less than m, and that's m is less than f of b. So therefore we can state, so therefore we can state, m equals 3 is between f of 0, which is less than 3, or m, we'll call it m, which is 3, and that's less than f of 2. And thus the assumption of the intermediate value theorem has been met. So we can conclude that there is some number c. There is some number c on the interval from 0 to 2, closed interval, which satisfies f of c equals m, which f of c is the 3x to the 5th minus 4x squared, and m is the 3. And that concludes this video and this problem. We've proved it. That we've proven that 3x to the 5th minus 4x squared equals 3 is solvable on the interval 0 to 2.